Hello everyone, today we'll talk about the problem all ancestors of a node in a directed acyclic graph. We're given this graph, this DAG, in the form of list of edges. We want to return a list of lists of ancestors of every node, and those ancestors should be sorted in ascending order. So for instance, when here we have a 3, then ancestors of 3 are 0 and 1, so that list should contain 0 and 1, and we have to do that for every vertex. There are two main approaches to solving this problem. One approach would be through graph traversals, and another would be to perform a topological ordering, and later I'll tell you why topological ordering is useful here. However, let's talk about the DFS solution. Well, the solution is very simple. First, we transform our graph to the form that's typically used, so adjacency lists. And now we just go through all of our nodes in ascending order, so through all the ancestors. We mark all the nodes as not visited, and we start a DFS or any other search, but in this case it's a recursive DFS, starting from the given node. And the role of that DFS is to write the number of this node in our answer for every vertex that we can reach. So when we are at the current vertex, our ancestor, so the starting vertex for this DFS is this, then if we should write it to the list, we do it. We go through all the other neighbors, and if they haven't been visited, we visit them. And after that, so after the DFS from vertex 0, we have 0 written on the list for everything that can be reached by 0. Then we go DFS from 1, and we write 1 everywhere that we should, and so on. So this is a very simple approach. However, this approach has the downside that it has this n times m factor in time complexity, because we go through the whole graph in each iteration, because in general DFS will take n plus m steps, because we look at every edge, we look at every vertex. Well, in this case we really look only on edges connected to the vertex n, but this factor n times m is important because m can be in general on the order of n squared. So that's one downside of this solution, but in this problem, this solution is enough. And how to solve this problem without this n times m factor with topological ordering? Well, let me go through it quickly, because notice that if we have this topological ordering done, then we can be sure that when we visit a vertex, then all the vertices that are before it must also be before it in topological ordering. So we have answer calculated for all those vertices. And in that case, the ancestors of this node are all those vertices and all the ancestors of all those vertices. So I can use that factor to make sure that this problem, well, to solve this problem and maybe drop this n times m factor. But it's really not necessary.